and we learned that we could use what was called synthetic division, which was kind of a crazy, weird, but fantastic thing to help us reduce polynomials so that we can then factor further. Okay, so at the end of your homework last week, you had problems where it was like, write it out and factor twice. So you had a bunch of bubbles. Well, we're going to do the same thing today, except we want to factor and solve. And so sometimes you can do that stuff by hand. So this is an example of factoring and solving by hand. We have 4 terms here. How do you factor that? Split it. This is factor by grouping. And so we look at the GCF of the front here. What can we take out of both of these? X squared. And that leaves behind x minus 3. And then we have the back 2 terms, and they have a greatest common factor. And what can we take out of that?
4.
A positive 4. And what does that leave behind? Good. And then we do that again and say, hey, now we have 2 terms, and they have an x minus 3 in common. So I can pull that common factor out again and say, hey, what's left over? X squared plus 4. Now, I can set each bubble equal to 0. Whoops. And solve for x. So I get x minus 3 equals 0. So I'm going to add 3. So I get x equals 3. And over here, we have x squared plus 4 equals 0. How do I solve for x on that? Subtract 4. So we get x squared equals negative 4. And then square. What do you have to remember when you take a square root? Plus or minus. Very good. Don't forget the plus or minus. So we get x equals plus or minus the square root of negative 4i, which is what?
Imaginary
2i. Imaginary 2, yes. All right. So that's really cool, and we can factor that by hand, and not factor by hand, but solve it by hand. Now, sometimes we can't solve by hand. And if we can't solve by hand, then we can use synthetic division and our calculators to help us do that. Okay. And that's because when we're solving for x. This is an x-intercept, which we can get from our calculator and sort of reverse it and use some division. Okay. Let's see. Example 1, solve each equation. So you probably want your calculators out eventually.
It's not me, AJ.
It's about to cry.
Here we go. Ladies and gentlemen, we have a trinomial. What should we try to do?
Try it.
Try to factor. Very good. X squared times x squared is x to the 4th. What times what is negative 12?
6.
Positive 4 and negative 3. And we could go further, but it's not necessary because right at this point, we can go ahead and set each bubble equal to 0. Whoops. And solve for x. So sometimes you want to factor further, but if we're just solving, then if we have x squared, we can solve that pretty easily. So I'm going to move the 4 over, so we get negative 4, and then do what? Square root, don't forget, plus or minus. So we have x equals plus or minus 2i, again, very good. And then over here, I'm going to add 3, and again, square root, don't forget the plus or minus. So we get x equals plus or minus radical 3, good. Okay, so I would just like to point out the fundamental theorem of algebra. The entire algebra reason. When we're solving for x, right here we have two imaginary solutions, positive 2i, negative 2i. Here we have two real solutions. It's a real number. Radical free is craziness. It's like 1.7 crazy. Okay. But it's two real solutions. And when you add those up, you get 4 complex solutions. So that highest power tells us how many complex answers we should get. In this case, it's 2 real ones and 2 imaginary. And there's all sorts of, right? And there's all sorts of tests that I'm not going to talk to you about, but there's Descartes' rule of signs, and there's the rational root test, and all kinds of stuff that is so not necessary anymore thanks to these bad boys. Okay? So yeah, there's a whole lot I'm leaving out. But the fundamental theorem of algebra says if you solve for x, you should have that many solutions. Okay, the highest power. Okay, what do you want to do over here for letter B? Okay, so think about that. Let's just think for a second. We've got 4 terms, so you're thinking factor by grouping? Is it going to work? No, it is not going to work. We could take a 4 out of here, but then we wouldn't have matching factors. Okay, so it doesn't factor by hand, and because of that, we're going to go to our calculator. So grab your calculators and go to y equals, and we're going to look at the picture of this polynomial, x to the 3rd minus x squared minus 8x plus 12. What are you expecting to see? A squiggle. Yes, a squiggle. Very good. It is a squiggle. All right. There it goes. There's our squiggle. So, ladies and gentlemen, whenever you use your calculator, you need to make a little sketch of what you're looking at. Just a little sketch. All right. And what we're going to do is we're going to borrow from the graph to help us do some division, some synthetic division. So what we want to do is from our picture, we want to look at one of the x-intercepts. What do you think looks like an x-intercept? 2 possibly, right there. -3. I'm more certain about -3. So I'm thinking -3, and so since that's supposedly a solution, I'm going to use that in synthetic division. You can. I'm going to have to do it. You can use trace and type in -3, and you can see it's a 0, an x-intercept. So it should work. It should divide evenly. It should have a remainder of 0. So I'm going to use some synthetic division from Friday. Let's see. What goes along the top of my box? 1.
-1, -8, and 12.
Very good. Okay. And then what was the whole synthetic process? Combine and multiply. Yeah. Okay, so 1 and 0 is 1, and then we multiply 1 times -3. -3. Combine. Multiply. Combine. Multiply.
-12.
Remainder. Very good. Okay. So what this means is, I guess I'll do it like we did. No, I'm not gonna. Okay. By using synthetic division, we just proved that x equals -3 is a solution for x. Then we have this quotient that's left over. Can you put this back in polynomial form for me? What would it be? Good. X squared minus 4x plus 4. And now we want to try and solve this thing. So what could we do to solve this thing? Yeah, we can double bubble. Can we?
Yes.
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 You're making a question.
Negative 2,
Yes.
negative 2.
X times X. What times what is positive 4?
Negative 2.
Negative 2. Huh, that's kind of interesting. So we get X equals 2. And what's happening here? It's happening again. Okay, ladies and gentlemen, that's really, really interesting. So it did cross, or it did hit here. It touched at 2. This, ladies and gentlemen, is called multiplicity. Multiplicity is when we have a repeated 0. And this was repeated 2 times. So we would say this is multiplicity 2, meaning it's being repeated. And that's basically just, there's 1 0 there that we can see. Now what's really interesting and what we're going to do in the next couple of days is actually take this information and then graph. So you'll notice when we only have the x minus 3, our graph passes right through. But when we have a repeated 0, it does something very different. It doesn't pass through at 2. I lovingly call this a bounce. You see how the graph approaches and it kicks off a bit? Okay, so that's a cool kind of graphical thing that happens when you have a repeated 0. Now, you should know that this is happening 2 times. This actually counts as 2 solutions for the third solution for a total of 3. Okay, so multiplicity is included when you add up all those solutions. All right, so there's only 2 real solutions here, but this one's repeated. We'll talk more about multiplicity later. Let's try a couple more here. Multiplicity. This is my favorite part of algebra, is how the zeros, the x-intercepts relate to the graph. Very cool. We have 0 equals x to the 4th minus x cubed plus 2x squared minus 4x minus 8. Well, what do you think? Can you do this by hand? No, I cannot. Possibly. Not that I know. So, because I can't do anything by hand here, I'm going to go x to the 4th. What shape do you think you're expecting here?
Squiggle.
A squiggle, squiggle, squiggle?
Yeah.
A squiggle within a squiggle?
Yes.
I think I heard somebody say something. So it's a 4th degree. It's a 4th degree. It looks kind of like a parabola. That's what it's. Yeah.
It's a parabola. You got drunk.
It's a drunken parabola. Yes. The 4th degree polynomials look very much like squared polynomials. In fact, we classify them as even powered or odd powered. Okay. So because it's an even power, they all sort of look the same. Lots of different things happen in the middle. But what we see are 2 real solutions. What are the 2 solutions that I can actually see? -1 and +2. Okay. So what I'm seeing is 2 real solutions. Where are the others? They're imaginary. Okay, that's what this looks like. That's an interesting question. They could do that. You could absolutely do that. Graphically, these are not doubled up because they didn't bounce, so there's no multiplicity here. But what happens is these are the 2 real solutions that we can see, and we're going to solve for the imaginary ones. Okay. Now I'm going to use my zeros with synthetic division. So I'm going to use -1 for no real reason, but -1 is a nice low number. What goes along the top of my box? 1, -1, 2, -4, -8. Good. And we're going to combine and multiply again. So combining, we get 1. Multiply, we get
Now 1.
combine, -2. Multiply,
-2.
combine,
4.
multiply,
-4.
combine.
8. 8. 8.
All right. Well, that's interesting. So we just proved that because we had a remainder 0, x equals -1 is one of our solutions. We knew that from the graph as well. We can do a couple of things here. Because those numbers look awfully friendly, I happen to know that I can factor by grouping here. Or I can do something even better, which is piggyback synthetic division.
What?
What?
I guess
Piggyback synthetic division. I have another 0, and I don't know about you, but I really like synthetic division. So what I'm going to do is tack on an extra little box here, and I'm going to use my other 0 that I got from my graph, because I sure think synthetic is faster than factor by grouping. All right, so now I can combine again. 1 and 0 is 1. And multiply. What do I get? 2. Combine.
0.
Multiply.
0.
Combine.
4.
Multiply.
8.
Combine.
0.
Remainder 0. So there again, we just proved that x equals 2 is another 0. All right, now I need to solve for the rest of the stuff here. So here is my quotient. What does that mean? X to the second, very good, plus 4. And we can solve that. We want to set it equal to 0 to solve for the zeros. Set it equal to 0 to solve for 0. Good. So I'm going to move that 4 over and then square root. Both sides, don't forget the plus or minus. So we get plus or minus 2i. So we have 2 imaginary solutions and our 2 real solutions. Isn't that interesting? Yeah, yeah, yeah. And in fact, if you have 4 real zeros, you could do 4 piggyback synthetic if you wanted to. All right. Here.
Wait, that's just the answer.
Yeah, these are solving for the 4 solutions. Yep.
Is there another one in this?
No. Last one. I don't know why this is different, but we'll see. All right. Can I do this by hand? No. So I have x to the 4th minus 5x cubed plus 7x squared plus 3x minus 10. Plugging that all in. What shape are you expecting it to see?
That's parabola.
Parabola-ish.
Dun, dun, dun.
Ooh, it's true.
Yeah, it's a trippy parabola again. So, yeah, anytime you have imaginary solutions, you're always going to get some weird little blip in the graph. It's kind of like, good question. I don't know. Yeah, it's.
Does it just pick a random one and like just make it fancy? Like, ooh,
So you can actually graph imaginary solutions. Well, you have different axes. Like you have a real axis, and then you have the imaginary axis. So you can actually plot like I plus 3, but it's just kind of worthless. All right, so we got a couple of imaginary zeros going on. What are our 2 real zeros that we can see?
-1 and 2 again.
-1 and 2 again. Huh. All right. So I'm going to go again and use that synthetic division. Along the top, I've got a 1, a -5, a 7, a 3, a -10. Remember, when you have synthetic division, you have to fill in any missing terms. That's what most people forget. All right, so I have 1. I'm going to multiply. Combine.
-6.
Multiply. Combine.
13.
13. Multiply. -13. Combine. -10. Multiply 10. Remainder. 0. Good. Ooh, this one, I definitely couldn't do factor by grouping. I could have done that here. Maybe that was my intention. But again, since I have another 0, I can do piggyback. Piggyback synthetic. So I'm going to use the other 0 on the outside there. All right, combining, I get 1. Multiply, I get
2.
combine. Multiply.
-8.
Combine. Ooh.
5.
5. There we go.
10.
All right. Remainder 0 again. Awesome. So doing that piggyback really is another way to prove that x equals -1 is an x-intercept. It has a remainder of 0. It evaluates to be 0, so it is a 0. And now I can take my quotient, convert that back to a polynomial. X squared
minus 4x plus 5.
No.
No. So does it factor? Oh.
No.
Doesn't factor.
No.
So what do you do if it doesn't factor? Quadratic formula.
Yay! Said no one.
Said no one ever, yeah. So quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared ac all over 2a. Very good. All right. All right, so for plus or minus 16 minus 20 is -4 all over 2. And I want to clean that up a little bit. What is the square root of -4? 2i. And we're going to divide each of those by 2. And that's going to give me 2 plus or minus I. Excellent. So if you can't factor, and if you can't just use the square root method, then you must resort to the quadratic formula. Okay? Any questions for me? Awesome. All right. Isn't that fun? This is why you need calculators for this class. Because believe me, you do not want to know the rational root. It's not actually that hard. But. All right. Here you go, ladies and gentlemen. Have fun.